So the principle on which this screw job works is similar to that of an inclined plane. So if one complete turn of a screw thread be imagined to be unwound from the body of the screw undeveloped, it will form an inclined plane. So you can see here. So let the P will be the pitch of the screw, D will be the mean diameter of the screw, alpha is the helix angle, and P will be the required required at the circumference of the screw to lift the load. Next, W will be the load that to be lifted, and mu will be the coefficient of friction between the screw and the nut, and tan phi will be the coefficient of friction. From the geometry, so you can observe here, this is from the geometry. You can conclude that, or you can find that, so tan alpha equal to P by pi d. And next is the load is being lowered here. So whatever the load is there, it is going to be lowered here. So therefore, the frictional force will act upwards. The frictional force will act upwards, and all the forces acting on the screw will be shown here. Normal reaction act upward, vertically upward, and weight will act vertically downward. So normal reaction will be the vertically perpendicular to the inclined plane. Next, alpha will be the helix angle, and next this P load, it is inclined at alpha with respect to the, and next it will be resolved as P cos alpha and P sin alpha, and in the same way W will be resolved as W cos alpha, W sin alpha. Okay. And next, first of all, resolving the forces along the plane. So first resolving the forces along the plane. So from this, you can write it down, P cos alpha. So here, this is the P cos alpha. P cos alpha equal to F minus, so frictional force that is acting along this direction, minus, in the same way, W sin alpha is going to act reverse to the frictional force F. So that's why F minus W sin alpha. W sin alpha. And from this, and now this is the resolving the forces, horizontal forces that you had to resolve. And now coming for the vertical forces. So from the vertical forces, you can write it down, Rn equal to, so vertical forces, Rn equal to, so W cos alpha, and in the same way, P sin alpha. So P sin alpha is going to act upwards, and W cos alpha is going to act downwards, and also Rn will be acting upwards. So that's why Rn equal to W cos alpha minus W cos alpha minus, you can write it down, P sin alpha. W cos alpha minus P sin alpha. So now we are going to substitute in place of Rn. We are going to substitute in the equation 1. So this is the equation 1. So from this, you can write it down, P cos alpha equal to, so F, that is F will be mu into Rn minus W sin alpha. You are going to substitute in place of Rn, you are going to substitute the equation 2. So from this, P cos alpha equal to mu into Rn is W cos alpha minus P sin alpha minus W sin alpha. From this P cos alpha equal to mu into W cos alpha minus mu into P sin alpha minus W sin alpha. So you can shift this. From this you can write it down. P cos alpha equal to mu into W cos alpha minus mu into P sin alpha minus W sin alpha. From this, you can shift this here. From this P cos alpha equal plus mu into P sin alpha will be equal to mu into W cos alpha minus W sin alpha. You can take it out P as common. P into cos alpha plus mu into sin alpha equal to W into mu cos alpha minus sin alpha. So from this effort required to lower the screw jack, you can give it as W into mu cos alpha minus sin alpha by cos alpha plus mu into sin alpha. We know that mu equal to tan phi. We're going to substitute that P equal to W into tan phi into cos alpha minus sin alpha by cos alpha plus mu into sin alpha. So in this mu, you can substitute tan phi. From this, W into sin phi cos alpha minus cos phi sin alpha divided by cos phi divided by cos alpha cos phi plus sin phi sin alpha by cos phi. So this will get cancelled. And now you can write it down as W into sin phi cos alpha minus cos phi sin alpha by cos alpha cos phi plus sin phi sin alpha. So you can write it down W into sin of phi minus alpha by cos of phi minus alpha. So from this you can write it down W into tan of phi minus alpha. Therefore, the torque required to overcome friction between screw and nut, you can give it as T equal to load into perpendicular distance, that is d by 2. So from this we now P as W into tan of phi minus alpha into d by 2. Where the condition, whatever the angle alpha helix angle is it is less than 5, then P equal to tan of, that is W tan of alpha minus 5. So this is about all.